Okay.
Good afternoon, everyone. Thank you for coming and attending Red Hat OpenShift Commons. Thank you for coming to participate in the Edge Special Interest Group. We have the amazing Mr. Diego Alvarez here. He's an Associate Technical Marketing Manager, and he's going to present to us today on single node OpenShift installation.
Okay, so hello everyone. Thanks for having me here today. So yeah, as Benjamin said, today we're going to talk about single node OpenShift and how to install it. So maybe some of you already know how to do it, but there were two reasons to why we wanted to show this here. The first one is because, well, maybe you have already deployed a full cluster, but you don't know exactly where do you need to specify the number of nodes, workers, and masters. So that's one of the reasons. And the second one is that this single node OpenShift installation is part of a bigger computer vision series that we have created. So this is just the first episode, but the idea is to keep doing more and more episodes during the next sessions. So we can see like the entire process from the beginning with the single node installation to the deployment phase of the computer vision application. So that were the main reasons to do this here on this call. So yeah, about me, I'm Diego Alvarez. I'm Technical Marketing Manager Associate. I'm working for the Edge portfolio, and also I'm starting to do some AI ML tasks. So this series combines both of them. So before doing or going directly to the demo, I would like to introduce the topic today. So let's talk a little bit about edge computing. So we call edge computing, we name edge computing all the applications and AI ML tasks that we perform at the edge. So typically you would like to have like big data centers, full cluster, because usually those applications needs a lot of resources. But there are a couple of benefits of running these applications at the edge. So here we have listed a couple of them. So first one will be faster decision making. So imagine that you have like a video camera recording and you want to process those images. If you are doing the detections on a big data center, you need to send all this information, process all the frames, and send back the information to the edge. And this is not efficient. So if we want to do something faster that can perform actions in real time, we need to reduce that latency. That's why we want to run application at the edge, and we don't need to connect to the data center. So that's one of the reasons. The second one, you may already know that one of the biggest problems, or we struggle a little bit at the edge when we have limited or no connectivity. So this is a problem that we can solve if we are running the applications locally on the edge device. Again, we don't need to send any of the information to a data center, so we can run our application autonomously. So it can be disconnected and the application will keep running at the edge. And the last one will be keeping the data secure, as we are not sending this information, pictures, video, or data coming from sensors. We're not sending this to a data center over the network. So this means that the data is stored in the same device where it's getting captured. So yeah, those are a couple of the benefits that we can see when we run applications at the edge. But here we are only talking about application, but what happens if we want to train models at the edge? So basically, we were thinking about which use cases could we have at the edge and why we will need to train models at the edge. So one of them could be, for example, having like a mobile platform on a ship in the middle of the ocean, for example. with some drones taking pictures for some kind of issues or detecting some kind of whatever. When these drones come back to the platform and you want to retrain that model because you want to adjust some little things or maybe adding new classes or data that you want to detect, you need to put all those images into a data center and train the new model there. So that was one of the reasons why it could be great to have some kind of data centers closer to the edge. And another example will be, for example, with social media platforms or streaming platforms. You all know these models or algorithms that suggest you the next video, the next movie or film. Those applications needs to be trained constantly based on your interactions with the application. So companies here are trying to deploy more and more servers at the edge, so this training can be done faster and in different regions. So there is no central data center where to train the model. So here we saw some examples. So we thought about moving the data center closer to the edge. So the problem we have always here is the resources. At the edge, we don't always have a lot of resources like hardware, GPUs, or power, for example. But Red Hat provides a solution that is a single node OpenShift that can fit in this scenario. So we came up with this demo that is divided in different chapters. So here you can see the diagram. What we call data center is what we are going to move closer to the edge. So we are going to deploy single node OpenShift on bare metal servers. But today also I will show you how you can do it also on the cloud, just in case you want to see how OpenShift AI runs on single node on AWS. And this data center will be at the edge. We are going to install single node there, and then we can install the OpenShift AI operator and all the dependencies, like some kind of storage. We can enable the GPU to speed up the training. And once we have this application or this operator running, we are going to train the model using YOLO. Let's talk a little bit about the application. We are trying to build a Safari application. Basically, it's a computer vision app that is able to detect animals in real time and gives you some kind of information about the detections. And the last episode of this series is about deploying the application at the edge with Microchip. But yeah, for today, what we have is just this part, the data center. We are going to show you how to install single node on bare metal and then on the cloud. So if there are any questions, we can continue with the demo.
Hey Diego.
Yep.
Is your SNO installed? Is it going to be IPI or UPI? And can you,
So
I guess,
yeah, we are going to use the assistant installer to deploy the single node OpenShift. So I have my bare metal node that is managed with an iDRAC. And what we are going to do is use the assistant installer. I mean, that's the tool I prefer. It's quite easy to deploy a single node there. So that's the one we are going to see here. So yeah, the first step will be going to the Red Hat Hybrid Cloud console. And in the cluster section, we can create here the cluster. As we are using a bare metal server here, we need to go to the data center and we can create the cluster. So as I said, this is quite simple. It's like a template where you just need to specify the values for the different parameters. And this tool will automatically generate a discovery ISO. I will be the one who manages the node that is going to be attached to this cluster. So we just need to specify the name here, the base domain that needs to match your environment. So in my case, the environment will be femlab rdo2.redhat.com. We can select the OpenShift version, the 4.15. will be the last one that I will use. The CPU architecture, my node is using Intel, so I will choose x86. And important steps comes here. We just need to click this box, install single node OpenShift, and it will generate the discovery ISO for us for this single node. So we go to the next page. This assistant installer will give us the opportunity to install some operators during the single node installation. So for example, as we saw before, we will need the LVMS operator, but for this demo, we wanted to show like the entire process. So we can skip this part, as we will see in future episodes how to install manually these operators. So we click next, and here is where we are going to import the real physical bare metal node. So the first thing will be selecting the image that is going to be generated for the discovery ISO. As we are going to use virtual media, I'm going to use the minimal image file. And we need to provide the SSH public key. So if I go to my computer terminal, I can get it from this folder. There's a typo here. So all I need to do is just copy this and paste it here. And we are going to generate the discovery ISO. So here is going to start the download. Hopefully it will not take a lot of time. What we can do in the meantime is go into the node. So as I said, I'm managing my node from an iTrack. So I will log in here. And yeah, this is my node. As you can see here, we can also open the virtual console. First of all, this node has two different GPUs. We are not going to see how to enable the GPUs in this meeting, but it's going to be something that we will need in the future, especially if we want to accelerate the training. So seems like the download has finished. So what we are going to do right now is to set up this node so it can use this discovery ISO to boot up. So it can be detected from the assistant installer. So what we need to do is go to virtual media and map this file. The discovery ISO, we just download it. As you can see, virtual media is connected, so we can close this one. And all we need to do right now is just restart the node. So if we go to configuration, system settings, here we are going to specify this server that we are going to use this discovery ISO during the boot procedure. So we can need to select virtual CD DVD ISO, apply, and now we can turn off and on the server. Okay, and now we can turn it on. Okay, so as you can see here, the machine is restarting. And in a couple of seconds, you will see that it's going to use this virtual media that we just specified. And when the installation finishes, you will see this node included on the host inventory. So yeah, let's see if we can see how the installation starts. And during the installation, maybe we can start seeing how to deploy the single node on AWS. Yeah, as you can see here, the machine will boot using the CD or the ISO that we specified. So yeah, in the meantime, what I will do is show you how to do the same steps on AWS. So let me open this here. So this is my AWS account and environment. What we are going to do here is creating two different machines. The one that is going to be the single node itself. But for starting and deploying the single node, we are going to do it from a host machine instead of using my own personal computer. This way, everyone can follow the instructions and everything is in the same platform. So yeah, for this host machine, we will need to create some networking configuration. So if we go to services, networking, we go to route 53. So this is the service that AWS uses to create the networking configuration. So the idea here is to create a hosted zone. As you can see here, I have already one created, but I will show you how to do it if you want to create a new one. So first of all, you need a new domain that is yours. If you don't have your own domain, you can register a new one from here. So for example, let's say that I want to use SIG.com. And if it's not available, AWS will give you some other examples that you can use. For example, I like this one, so I can select this domain checkout. Here we can select, specify the duration of this domain, if we want to renew again, etc. And all you need to do is just complete all this information and purchase this domain, and it will create automatically a hosted zone for you. So that's all you need to do. But as I already have one of them, I will show you the one that I created before. This is the one I have, and it's going to route all the traffic to these servers. So this is what we are going to use for the single node, but also we will need to create a virtual private cloud for the host machine. So we can do it also from here, networking, VPC. So this VPC will help us to deploy the instances. If we don't want to expose it to the internet, we can use this configuration to keep using those instances. So all you need to do is go to VPCs, actions, and create a default VPC. And that's it. The default parameters works, and we will use it later during the host creation. So before continuing, let me see how is this going. Okay, so as you can see, it's progressing. What it's doing right now is deploying all the components needed so the node can be detected from the assist installer. So yeah, we will see later how it goes. So back to the AWS, the next step before start creating the instances will be creating a user. So if we go again to services, we can create new user from the security, identity and compliance tab here in the identity and access management section. So as you can see here, I have two different users, but I will show you how to create a new one. So all we need to do is just specify the username. I will write my nickname. Next. And we are going to create a group so this user can have the right permissions. So the group name will be admin. And I will add this permission that provides full access to all the services in AWS. So we can create this user group. And finally, we can create the user. So this is my new user, but we also need to create the credential that we are going to embed during the SNO installation. So we need to go to the security credentials, SSH public keys, and we are going to, oh no, sorry, access key, and we need to create this access key. I will give it the command line interface permissions. So I will select that one. We can skip this description. And here we have all the information for this user. As we will need it later during the installation, what I would recommend you to do is copy this access key and the secret and paste it somewhere else, so we can use it later. Okay, so that's all we need right now. Of course, I haven't seen this. And as you can see, this access key is the one that we just created and the one that is attached to this user. So at this point, all the configuration is done. So we can start using this or creating the instances. But before that, let me see how is it going. I don't know, are there any questions in chat or? Okay, no, I can't see any of them. So let's go to the instances creation. We can do it from the compute tab, EC2. And here is where we are going to create the host machine where we are going to use for launch the SNO installation. So we can click on launch instance. The name will be host. And here we can keep the default parameters. We are going to use this ANI, this Linux, and the architecture will be x86. And for the instance type, I will select another one to ensure that it has enough power to launch the installation. So for example, this one should work with 8 virtual CPUs and 16 gigs of memory. And also we are going to create a key pair so we can later SSH into this machine. So we'll go to create, and it will be my keys. We are going to use RSA and PEM extension so we can create the key pair. So we continue with the configuration. Under network settings, you can see that the VPC that we created before is already selected. We can select other like subnets here, but this one should work. So as you can see, it's quite easy to configure this machine. The storage is already configured. So at this point, we can launch the instance. It shouldn't take too long. Okay, so now the instance is ready. What we can do is connect to this instance. So here you can see some steps that we need to follow to connect into this machine. So the first one will be giving the right permissions to the keys. So I will copy this command. I will paste it here, but we need to change the path to the keys. So that will be under download my keys. Oh, let me see. Oh yeah, there was a typo here. So we gave the right permissions to this file, and the next command will be the one that give us the possibility to connect to this machine. So again, all I need to do is change this the path to the keys, and that's all. Yes. Okay, here we are. So this is the host machine and the machine that we are going to use for firing up the installation. So before continuing, let me see how is this installation going. So seems like it has finished. So if we go to the assistant installer, you can see here that the node, the bare metal node, has been already detected and is ready. So we can continue with the configuration. The storage is already configured, so we don't need to change anything here. The networking is also detected automatically. So here, for example, we can select the subnet that we want to use, but in this case, we can keep the default parameters too. So here we have a summary of all the configuration, and if everything looks great, we can start installing the cluster itself. So yeah, as a summary, what we did before was installing the discovery ISO, so the server can be imported to the assistant installer. And now that it's detected, what we are going to do is installing the single node itself. Okay, so all we need to do here is just waiting for the installation to finish. So let's go back to the AWS machine. So the last step we did was connecting to this host machine. And the next step will be to create an SSH keys. So all these steps are documented on the blog post. So this is the first blog post of the series. Here you can see the list of all the different chapters. So today we are doing both the first and the second one. Also, if you want to watch a video with all the details at the bottom of the blog post, you can see it. So we already did all these steps. We just connected to the host machine. So we can now create the SSH key. We're going to copy this. Going to paste it. So we have generated the keys. Also, you will always have access to the official documentation. So in case you want to learn more about how to configure something in one specific step, you will always have the opportunity to go to this documentation. So yeah, as you can see here, we have the same commands. So the next one will be evaluate the SSH agent. So we can paste this one. And finally, we need to add the private key we created. So I'm going to copy this command. I'm going to paste it here. And I'm going to specify the path to the private key. Okay, so as you can see, the identity has been added to the agent. So we can jump to the next step. Let me show you the next one, which will be actually start creating the installation script. So, well, actually, there's another step that we need to do before. We need to download the installation packages and also the OC command line packages. So we can get those from the hybrid cloud console, the one that I showed you before when we were creating the bare metal cluster. There is a section here, the download section, where we can see all the packages that we can download. So this is the first one we need. The operating system will be Linux, as this is the one we selected before. And as we are going to trigger the installation from this host machine, instead of downloading these packages into my personal computer, what I will do is copy this address and we'll download them with wget. Okay, so now we have the OpenShift client, and the next one we will need will be the installer. Again, we can select Linux, copy link address, and wget. And here we have both packages. So the next step will be AMP3, both of them. So tar and we're going to repeat this command for the second file. Okay, so we have here all the packages. So actually we can delete this one. And also I will delete the other one. And oops, sorry. Yeah, the next step will be moving these folders to the path. So if I go to the blog post, here you can see that we are going to move the OC folder to the local bin, the kubectl, and the OpenShift install. So we'll copy this command. We're going to copy the next one. And we should be ready to start the installation. So if we run OpenShift install version, we should see that we are going to install the 4.15, 16 version, and this release image, etc., and the architecture. So I hope everything is clear until this point. Let me see how is this installation going. Okay, so there is some progress here. So if we go back to the AWS installation, we are going to create the install config file. So here we are going to specify all the parameters that we need for our single node. So here what we have is like a wizard, but it will create a YAML file that we can later edit if we want. So we can select the SSH public key we created before. The platform we are using here is AWS. And here, do you remember that I asked you to store the access key and the secret? So this is the moment when we need to use it. So if I go to the access key, copy, paste it here, and now the secret. And now we can select the region. In my case, I will select Europe, North. And here we can see the base domain. This is the hosted zone that we created right at the beginning. Now we can select or type the name for this cluster, will be SNO. And we will need also the put secret that we can get also from the Hybrid Cloud console. Under downloads, if we go to the bottom, we can see here the put secret, copy, and paste. That's it. So if now we run ls, we should see that we have created a new install config YAML. So let's take a look at it. So here you can see that it has automatically created this YAML based on the input we provided before. So we are using this base domain, the pull secret, etc. And here comes the important part if we want to install single node OpenShift. So as you can see, by default, this installer will deploy a full cluster with 3 worker and 3 master nodes. So here is where we can specify the number of workers. As we are going to use single node, we need to write here 0. And for the master, 1 master. Also, if we don't specify the platform, the default one will be assigned. But as we will need later for the training GPUs, it could be great to modify this platform and specify the one that we want to use. So all we need to do is type in those lines, AWS type, and here we need to select the instance type that we want to use. So we can see all of them from the AWS documentation. I already have it here. So yeah, as you can see, there are several different instances that we can use depending on the purpose. So we want accelerated computing. So here we have different options with GPUs, but also when I explain, well, let me show you the diagram. I told you that we are going to deploy this on the edge, but in this demo, also we wanted to give an alternative if you don't have an edge device where to test the application. We recommend you to use virtualization, OpenShift virtualization. So the problem is that if you want to run OpenShift virtualization on OpenShift, you need a bare metal server. And this means that you will need a metal instance here. So the ones that provides, for example, both GPU and metal instance type will be, for example, G4DN Meta. That will give you some GPUs and also will be metal. So we can install virtualization later. So yeah, remind just a summary. Here is where you can select the instance you want. So if you want just the GPU, you can select any of these. If you want to run OpenShift virtualization, you can find other metal instances. If you want both, you can select, for example, this one. So here you have lots of options. But as we are not going to show today how to deploy OpenShift virtualization, or we are not going to train the model today, I will keep the default one. And that's it. We can close this install config YAML, and finally we can create the cluster. So what we need to do is copy this command and run the install create cluster. And here the installation starts. So this process takes quite a lot depending on your internet connection, and taking into account that I'm sharing my screen, it will take even longer. So hopefully if we go back to the bare metal SNO, maybe we already have it working. Okay, no, so we still need to wait a little bit to have it working. But yeah, the goal for this meeting was to at least show you the OCP web console, at least from the bare metal server. But yeah, also you have all the information on these videos. So maybe you can see here how the output looks like when the installation finishes on AWS. So these are all the steps we just follow. As you can see here, we are specifying the instance type. And this is the accelerated version of the installation. When the installation finishes, you will get the console URL, you will get the kubeadmin and the password. So all you need to do is just run the export kubeconfig on your terminal, and then access the console and use these credentials to log in, and you will be able to start using your single node OpenShift. So that's how it's done on AWS. And maybe I think we still have some time. So maybe we can wait a little bit for this installation to finish. And maybe we can talk about the other chapters of this series. So for example, one thing that I would like to mention is that for later in future episode, we will need to install some kind of storage on the cluster. So my bare metal server already has a separate disk with enough space. But for example, if we want to add some storage to the AWS single node, there are some extra steps we need to follow. So all of them are already documented here in the video. But yeah, maybe I can show you how to do it. So if we go to the EC2 dashboard, where's my list? Here. You can see here a couple of instances that are being created. So here in volumes, we can create new volumes and attach them to the single node that is going to be created. So let's take a look to this. So here we have the EC2 instance that we name host, and that's the one we use for starting the installation. And this is the machine that is being created right now to start deploying the single node OpenShift. So when it finishes, this install will be deleted and a new one will be created with the final single node OpenShift here. So yeah, let's see how is this installation going. 80%, so it's finalizing. So basically here, when it finishes, what you will see is, again, the OCP web console URL. You will get also the credential for the kube admin and the password. And that's all you need. In this section, the cluster section, you will see all your clusters. So this is the one that we are finishing deploying right now. So yeah, we can always track the installation here. So yeah, about this series, the idea is to keep expanding with other episodes. So for example, with OpenShift AI, we are training the model. We are embedding this model into a container file so it can be pulled later from the edge device. But the power of OpenShift AI comes when we use model serving, pipelines, etc. So this is not shown here yet, but the idea is to keep expanding this series with new chapters. So yeah, if you want to learn how to serve model from this single node so it can be run on the edge, we'll create a new blog post. And another one will be how to enable GPU acceleration with microchip, so we can speed up also the detections at the edge. So it should be ready soon. Here we can see some events that are happening in the cluster. So yeah, we will give it some extra time. Also, we can see in the meantime how this installation is going. So yeah, as you can see, the installer is trying to install OpenShift for the 15, is using the SSH key, the base domain, the platform we specified in the YAML. And now it's waiting up to 20 minutes to have the API ready. So this is going to be the most time-consuming part, but I usually have it running in 30 minutes or so. So as you can see, it's quite easy to start using single node OpenShift. In just 1 hour, you will have it ready for you, and you can start deploying operators and all you need there. So let me see if there are any other questions.
Hey, Diego, I have a question.
Yeah, go ahead.
So are you suggesting that maybe the best way for us moving forward, I know you talk about these other sessions, but that we need a combination of using an AWS account and something at home for Edge Home Lab, or an Edge Home Lab really needs something else besides you having that server at home?
No, not really. So these two different chapters are, so you can select the one that you prefer. So there is no need for combine both to increase the power to train the model. So yeah, all you need is just a bare metal server if you want. So if you want to run this on your lab environment at home, all you need is a single node, a physical machine. If it has a GPU, that will be better. But also, this will be the case for when we want to go to production, maybe. So this is the real case. But if you want to run this demo at home and you don't have all these devices, for example, you can use OpenShift on AWS. So it can be easily followed.
Okay. Is there any typical favorite mini PC you have, or what's the smallest, most effective unit that you've seen tested in a home lab that was affordable?
So I'm not a big expert on which one I would recommend. So probably you will
If I can
find.
comment a bit on that, maybe.
Yeah.
So one device I like very much for computer vision at the edge, for running inference at the edge, and that's pretty cost effective, would be the Jetson Orin Nano. That's in the $500 price range. Pretty efficient. It got GPU. It's an ARch device. It's soon to be officially supported, so you won't find it yet in the supported devices, but the RPMs to support it are to be released this or next week. So yeah, stay tuned for announcements there. So this would be one of my recommendations. Another one, well, to be honest, any NUC-sized PC like x86, even without a GPU, would allow you to run some inference in CPU mode. And when it comes to certified hardware, that's where you will find the most cost-effective ones. And that's also if you want x86.
Okay, that is great. I got that was a Jensen Nano RN9 Nano.
Jetson Orin Nano.
Okay.
Let me write it in the chat.
Okay. Does anyone else have any other questions?
No, seems like everything is clear. So yeah, I don't know what to do, if we should wait, or maybe I can just show you from the video how it will look like. But as I said, it's just the URL to the web console and the credentials for the kubeadmin. So one of the like things I like to do when I create a cluster here is using the identity provider, set up an identity provider on the cluster, so we can so you can create new users with the same privileges or permission as the kubeadmin has. So you don't need to keep these credentials here, because at some point it disappears from this platform. So my recommendation will be, once you have the single node ready, create an identity provider, create your user, give it the right permissions, and then you can, or keeping the kubeadmin user, or maybe you can delete it also. But yeah, let's see if we see some progress here. Let me show you in the meantime the bare metal blog post. So here you have the same introduction, the diagram that we saw before, and all the steps to complete the installation from the assisted installer. Here we were mapping the device, you remember, and once this Discovery ISO is installed, it will appear here. The network will be detected automatically, and this is what you will see when the installation finishes. So you will see a green bar, and if under this bar, you will get the web console, the cube admin, and the password. So if you need to update your DNS, it will give you this command. So all you need to do is add these entries to the DNS if you cannot open the web console, and that's it. So yeah, the output when the installation finishes should look something like this. But we are still stuck here finalizing the process.
Diego, an amazing demo and talk. I think we all really enjoyed it, and we do look forward to the next steps because this was a great thing. And I guess we all need to get this down like the back of our hands as sooner than later. So yeah, it looks like a training roadmap, seriously.
Yeah, exactly. So here you will learn how to do everything. So one of the ideas behind this demo was also to show how all the different pieces works together. So we are using a storage, we are enabling the GPU, we are using OpenShift AI, we are using Quai for serving the container image, Microchip. So yeah, as you can see, this was also something new for me. So this was like a learning path that I had to go through, and I wanted to also like create resources from me. So because at the beginning it could be a little bit overwhelming seeing all these different pieces, and you don't really know exactly how they interact each other. But yeah, finally, if you see an example like this one, you can see that it's quite easy following the documentation, and it works quite well. So yeah, I will give you access to the, well, access not, I will send to you all the blog posts. Well, actually I have here. So these are the links to the blog post, the one that we saw here, and also to the videos. And as I said, you can also jump to the other section that you want to learn, and everything is linked and everything is explained here. So yeah, what we can see, we will see on the next episode will be the installation of OpenShift AI. So there are some underneath like requirement, as I said, storage. So when we use single node OpenShift, we cannot use Ceph, for example. We need to use LVM storage. So that's one of the operators we are going to install. We need to install the node feature discovery operator to expose the GPU, and also use the NVIDIA GPU operator to manage this hardware. And when we have everything ready, we should be able to install OpenShift AI. But yeah, this is something that we will cover on the next episode. So yeah, stay tuned if you want to learn more about OpenShift AI.
Diego, again, thank you so much for your amazing presentation. Is there anyone who has any more questions or concerns? Because it's the top of the hour and we just are going to, I guess, get ready to everyone go back to their rest of the day.
Thank you so much, Diego. This was great. Thank you.
Thank you so much.
Okay, everyone. So I guess this will conclude us, and we can, I guess, stop the recording. And again, thank you so much. And we look forward to the next episode, and anything we can do to chime in, you know, we would love to maybe follow up on Slack and keep this and grow our community.
Exactly. If not, I will see you in 2 weeks.